Hi everyone, I'm Rishabh Sharma, and I will be giving you an introduction to Web3. So I'll be going over the differences over Web 1 to Web 2 and to Web 3, and I will be giving a brief overview of the blockchain technology. I will also be talking about Solidity, smart contracts, ABI, and the different types of smart contracts, the ERC20 and ERC721. Let's start with Web 1 and an overview of how the internet was. So Web 1.0 refers to the first stage of the World Wide Web. From 1989 to 2005, you could only read the data from static websites on the internet. So when you loaded a website on your computer, it just a bunch of information and that was it. It was like an encyclopedia, so it was pretty boring. The websites were built by companies, and the users of the internet were mostly consumers. As we can see from these images over here, this was the website of Apple.com, Walmart.com, and MSN. This was in 2004 and 2001. Web 2.0 started from 2005 and it started gaining popularity. It is an enhanced version of Web 1.0, and Web 2.0 is also called a participative social web. It does not refer to any specific days over Web 1.1. Rather, it refers to the modification in the way we interact with the web pages. So Web 2.0 is about reading and writing data from the web applications. The biggest change in Web 2.0 was its interactivity. So instead of web pages just providing us information, we also started sharing information with the web. And we would willingly share this information for better personalization and for creating a community. So, for example, I'm sharing this presentation with you right now on YouTube, and similarly, you can share your opinions and thoughts in the comment section. And this sharing of information is critical to building community. But there is one major limitation about Web 2.0 is that we interact with the internet more. These websites collect our data for better personalization, but these companies can also sell these data to advertisers. So Web 2.0 is a lot of targeted advertising, and there is lack of privacy in Web 2.0. So Web 3.0 is gaining a lot of popularity now, and Web 3.0 is the next evolution of the internet based on the blockchain technology and the tools of decentralization. In Web 3.0, instead of the companies being the owner of our data, it is us who become the owners of our data. Web 3.0 consists of blockchain applications, which are more commonly known as decentralized app or dApps. Uh, the benefits of Web3 applications are that they are verifiable, trustless, permissionless, distributed, and robust, and an, there is native built-in application payment support. It is verifiable because it is built on blockchain technology, which is encrypted and it can be calculated through proof of work. It is trustless because there is no intermediary company which monitors the blockchain. It is permissionless. You can access any of the information that is there on blockchain, and once it is uploaded to the blockchain, it cannot be changed. So now let me give you a brief overview of blockchain. In Web3, developers build and deploy applications that run on the blockchain. Blockchain is a distributed ledger that are completely open to everyone. They have a unique property that once a data has been recorded on the network, it becomes next to impossible to change it. Uh, a blockchain collects information together in groups known as blocks, and these blocks hold a set of information. Each block has a certain storage capacity, and when filled, these blocks are closed, and then they link to the previous block, forming a chain. This is known as a blockchain. Now, each block contains data, uh, and a hash of the block, and a hash of the previously linked block. The hash of each block is unique, and once a block has been created, its hash has been calculated, and it changing any of the data inside the block changes the hash of the block. So we can never change the data of an existing. This also helps us in verifying the block in the chain. As we do proof of work and we find that a certain block has been altered, its hash value will change. The block which is in front of it has a value of the previous hash, which does not match in the proof of work. So we can never alter an already present block. Now, to interact with the blockchain, we have smart contracts. And smart contracts are simply small programs that are stored on the blockchain and they run whenever a predetermined condition. So a smart contract works by following simple if, else, then statements, and these are written into code on the blockchain. Whenever a specific condition is met, a network of computers executes this code to perform the action. So, for example, in this, suppose, for example, I want to buy a chocolate from a vending machine, and the vending machine has a smart contract where the condition is that if a required amount of fund has been specified, then it will execute the action where it will release the product. So once I send once I send the money to the vending machine, the predetermined condition of the vending machine sending the money has been met and it will release the product. So what are the benefits of smart contracts? Smart contracts are fast, efficient, and accurate. Smart contracts are transparent because everybody has a copy of the transaction. Everybody has a copy of the ledger, and they can verify the proof of work whether the transaction is valid or not. It is also secure. So blockchain transactions are encrypted, which makes them very hard to hack. And hackers also have to go through the whole blockchain to verify the proof of work to alter any data, which makes it next to impossible. Now, talking about Solidity. Solidity is a high-level objected language for implementing our smart contracts, and we can create. It acts as a tool to write our machine-level code and compile that to Ethereum virtual machine. For example, we have a block of code over here. This is a contract of hello, where in the constructor uh, it gives a message of initial data to the parameter message. There's also a function of set message if we want to change that data to a different message. Uh, Now moving from Solidity to ABS. Uh, ABIs are application binary interfaces, and an ABI is the interface between two program modules. So one which is often at the machine code. So it is the interface between our application and the blockchain. So ABI defines the structures and methods that our compiled application will use to access the uh, external library on the machine level, and data is encoded according to its type as described in this specification. So in this contract, we have two methods specifically. One function is the transfer function, which takes two inputs, and we have the input two, which is the sender's address, and then there's the amount. So in two, we specify a hash value, and in amount, we specify the amount of cryptocurrency or the tokens that we want to send. The second method that we have is the get balance method. And in get balance method, we have a parameter of account where this function returns us the balance of the specific amount that we want to get. So smart contracts get compiled and into bytecode and ABI, and then they are deployed on the contract address. Now, the contract address is the Ethereum blockchain, where they are executed whenever a condition is met, or in ABI is called. Now, talking about the different types of smart contracts, I'll have to first give you an overview of the tokens. There are different types of tokens. Tokens like DeFi tokens, government tokens, security tokens, non-fungible tokens. But I'll be talking mostly about DeFi tokens and non-fungible tokens. So technically, token is another word for a cryptocurrency or a crypto asset. DeFi tokens are tokens that are equal to any other token. So all the cryptocurrencies are example for this. One token of Ether is equal to another token of Ether, no matter their value. So, but in non-fungible tokens, they are unique and they are often used as collectible tokens, collectible items. And in each token of an NFT has a different value as another token. An example of this is the Bored Ape NFT, which has been very popular right now. Talking about smart contracts, there are two major smart contracts which I use. One is for the fungible tokens, which is ERC20 contracts, and the ERC721 contracts, which is used for non-fungible tokens. Now, ERC stands for Ethereum Request for Comment, and the ERC20 standard was implemented in 2015. An ERC token contract keeps track of fungible tokens, which means that all tokens are the same. And ERC20 contracts contain several functions, but they have to meet specific methods to be called ERC20 standard. These methods are the total supply of balance, transfer from, approve, allowance. Total supply provides the information about the total token supply. How many, for example, how many bitcoins are there in the blockchain? Balance of provides us the account balance of the owner. Transfer method, it executes the transfers of a specified number of tokens from one wallet to the wallet. And transfer from executes transfers from a specified number of tokens from a specified address. Now moving on to the ERC 721 contracts. ERC 721 is a more advanced standard than ERC20. It is built upon the ERC20 standard, and it is a standard for representing the ownership of non-fungible tokens. That is tokens that are unique. So to make each token unique, we need to find out first who owns this. So we have a specific list of methods that ESC 721 standards has to make. Some of these functions are owner of. Now, owner of function gives us the information that who owns a specific token. And another method is safe transfer from. So safe transfer from safely transfers a token from from the receiver's address to the sender's address. And it also checks if the 721 protocol prevents tokens from being forever locked. Now, ERC for decentralized applications, we also have to talk about crypto wallets. as they help us interacting with the blockchain, and they are key values. So unlike their name, crypto wallets don't actually store our crypto. Our crypto or the tokens that we own is actually held on the blockchain, and the crypto wallets contain our private keys as well as public keys. So crypto wallets help us to interact with the blockchain and with these keys, and they provide us the ownership of our digital money, and we can uh, also make transactions using crypto wallets. So if I want to send a certain amount of money, I can go to the crypto wallet and I can run the command transfer, which will transfer a specific amount of money to a different address. Yeah, thank you.